Hello students, today I am going to discuss with one more chapter, new chapter called Gravitation. In this gravitation, I am going to discuss with gravity, gravitational force, universal gravitational law, importance of gravitational law, relation between G and G, difference between G and G, free fall, acceleration due to gravity. Okay, next, before going to this, we must know what do you mean by gravity. Gravity is nothing but it is a small force of attraction which exists between two objects, okay, where objects has certain mass. So for example, earth and moon, or here you all are observing one apple is there, another one is on orange is there, it has its own mass, okay. So but remember, between two masses, okay, there will be force of attraction. So that is nothing but force of attraction, that is nothing but a gravitational force of attraction, remember. So as we increase the distance between these two objects, then what will happen, the force, gravitational force of attraction will goes on decreases, the effect will be less. As you decrease the distance between two objects, then gravitational force of attraction or gravity effect will be more, okay. So that force itself is called gravitational force, and gravity means it is the smallest force of attraction which exists between two objects, okay. Yes, next, remember, gravitational force or gravity, it always attractive force between two objects which has certain mass, and it is measured in terms of Newton. Remember, strength of the gravitational force which depends on two factors. First one is mass, I already told you, and second one is distance. We know as you increase the mass, okay, then the force will be goes on decreases. How it is? It is just because of this equation, F equal to G m1 m2 divided by r square. F here, F is directly proportional to m1 m2 and inversely proportional to r square, means a distance. When m value is increases, F also increases. When r value increases, F will be goes on decreases, means when distance increases, force will be goes on decreases. When, okay, distance is decrease, force will be goes on increases. This is inversely proportional, okay. Hope you understood. This is basic law, you already studied in ninth standard, I think, okay. Next, Newton's law of gravitation, what it tells, force of gravitational, okay, or force of attraction is directly proportional to product of the masses and inversely proportional to square of distance between them. Remember one more thing, the gravitational, universal gravitational law, it can also be treated as, okay, inverse square law. Why? Because force is inversely proportional to square of the distance, means as you increase the distance between two objects, force will be goes on decreases. As you decrease the distance between two objects, the force will be goes on increases, okay. F and r square, they are inversely proportional, okay. Importance of universal law of gravitation. Remember, in our solar system, all planets are revolving in a specific orbit around the sun. It is just because of gravitation. Not only this, our atmosphere which is present on the earth, it is just because of what? Okay, gravitation. And flow of water or rainfall, snowfall, the motion of the moon around the earth, occurrence of tides, these all things which comes under, okay, gravitational force of attraction. Okay, yes. Next, see here, I already told you tides will be, okay, happen, it is just because of variation in the gravitational field. Okay, so I already given here brief idea, just go through this, you will come to know that what exactly it is. Okay, remember, always gravitational, every piece of matter in the universe, no matter how large or small, it pulls every other piece of matter. Yes, remember, which has more mass, that one attracts the lighter mass which is nearer with it. Okay, so for example, sun and earth. Okay, sun has larger mass than that of earth, so there will be gravitational force of attraction, it always try to pull, sun always try to pull the earth towards it. Okay, so like that, every, okay, every objects, or you can say in this way, every heavy objects which tries to, okay, attract lighter objects which is nearer to it. Okay, yes. See, remember, I already told you distance and gravity, the relation between distance and gravity. So F is inversely proportional to r square. See, why don't we fly off the earth towards the sun? It is just because of what I already told you, sun has more massive than that of earth. Okay, due to the gravitational force of attraction. Okay, see here, on the right side I already given one picture, that one shows due to the force of attraction, strong, okay, gravitational force of attraction, so we can walk, we can run, okay, we can live, okay, on the surface of earth. It is just because of gravitational force of attraction. Next, see, I already told you, okay, moon is the natural satellite for earth. Moon will revolve in a specific orbit around the earth. It is just because of there are two forces will balance, one is centripetal force and one more is gravitational force. Due to the balance of these two force, it moves, okay, it revolves, you can say, it revolves around the earth with specific orbit. Okay, see here, with these two, okay, diagram which tells the importance of gravitational force as well as centripetal force in our daily life. Okay, see, this is the one more picture I given, which tells the importance of gravitational law, universal gravitational law in solar system. Okay, okay, how the gravitational force, okay, plays an important role in solar system. So this picture itself, it tells. See, gravitational field, what it means, a region, it is a region which tells about what, gravitational force of attraction. That region itself is called what, gravitational field. In this field, if any object enters, that, okay, that experience what, force of attraction. If any object comes within that field, then what will happen, it suffers from what, force of attraction, that is called gravitational field. Okay, next, relation between G and G. G means gravitational constant, small g means acceleration due to gravity. So for example, if any object which is placed, okay, above the surface of earth, let us consider here red mark. Okay, I already mark a red mark, so it has certain mass. Consider a object, it has mass small m, then capital M is the mass of the earth. This object is placed above the surface of earth, and we know the radius, or you can say in this way, if I place any object above the surface of earth, the distance between this object and earth center, that distance is called r. R is called, okay, distance. So in this case, remember, when that body freely falling, or when that body, okay, suffers force, okay, force of gravity, so that force is called, okay, F equal to m into g. Don't write a means acceleration. But once we place any object above the surface of earth, if it is freely falling or if it stays there only, it's not matter. Okay, if it stays there only means it comes under what? Gravity. Why? Because that object is now in, okay, air medium, right? So it will gives you F is equal to mg. So from this we can say g equal to gm divided by r square. Okay, hope this derivation is there. I am not, okay, explaining all those things. So only equation we require. Why? Because derivation you already derived in 9th class. So same concept it is there in class 11, okay, in first pu. Let's see in that chapter. Brief, I will give you brief idea, that's it. Okay, next, we already discussed earlier chapter, that is acceleration due to gravity. What do you mean by acceleration due to gravity? When a body freely falling, its velocity will be goes on changes under the effect of gravity. When the velocity of that particular object goes on changes, it is nothing but acceleration under the effect of gravity. That indicates what? Acceleration due to gravity. Hope you understood. When a body freely falling towards ground, okay, then every time its velocity will be goes on changes, means acceleration it will gives you under the effect of gravity. That is called acceleration due to gravity. Okay, see here, every time, see, when time is 0, okay, when time is 1 second, when time is 2 second, every time, okay, its distance as well as its velocity goes on increases. So it comes under acceleration due to gravity. But which force will comes? Gravitational force, downward force. So that's why gravitational force can be denoted as m into g. Don't write m into a. So it is m into g. G indicates here gravity. Okay, see, this is also very important. See, in this case, apple is freely falling. So there are two forces will act on this apple. One is air resistance, upward direction. Another one is due to the weight, gravity. Gravitational force is downward direction. Due to the, okay, more surface area of this apple, so more air resistance will be there. So it takes some time to reach ground. Okay. So for example, if I throw a coin is a, okay, less surface area comparatively this. Okay, if I drop apple as well as small coin, 1 rupee coin, then what will happens? The time will varies. Okay, coin will reaches, okay, first, then apple will reaches. Why? Because it is just because of air resistance. For more surface area, it will gives you more air resistance. Okay, it will opposes, and it will gives you opposition for that particular motion. Okay, it takes its own time to reach the ground. Next, remember acceleration due to gravity, it varies with altitude. Remember, once we move above the surface of earth, then the g value will be goes on decreases as we move, okay, away from the earth's surface. The g value will be decreases as you, okay, as we know in this diagram. Okay, g value will be goes on decreases when we move, okay, away from earth's surface, or once we move in upward direction. See, free fall, I already told free fall means under gravity. Okay, in case of free fall there is no change in direction takes place, but the magnitude of the velocity will be changes, means acceleration, it will gives you acceleration every time, every second. Okay, velocity will be goes on changes. Okay, so of course the acceleration, okay, it will gives you. See, this is the data what I given, how acceleration due to gravity will varies at different location on the earth's surface. Remember, it's not constant everywhere. Okay, so slightly changes will be there from place to place. Okay, so this is just, okay, just for information, for general knowledge I given this. Okay, okay. Next, what is the relation? We already know g is nothing but acceleration due to gravity. Capital G means gravitational constant. Then small g value is 9.8. Capital G value 6.67 into 10 raised to minus 11. Then remember, small g always depends on distance and masses, but it is independent of distance and masses. Why? Because it is a constant part. Okay, so proportionality constant this is. Then SI unit for G is meter per second square, but this one is SI unit is Newton meter square kg per square. Okay, yes, last one, that is weight and mass. We already discussed in law of motion chapter also. Weight is nothing but which comes under gravitational force. Mass is indicates what? Quantity of matter. Okay, so weight is independent, weight is always depends on gravity g value. Why? Because W is equal to m into g, so it always depends on gravity, but mass always constant or same everywhere, it not change. Okay, yes, but weight may be vary from, okay, planet to planet. Okay, I already told these things in earlier slide. Okay, hope you understood these things. Just try to refresh, okay, what we studied, okay, in previous chapter also. These all are basics things, so which will help you to understand better in further class. Okay, thank you.